Hello, Algebra 1 folks. It's Miss Strong here, and I am ready to get you ready for Homework 2. So we are working on homework in our video 2. I hope you have already read and taken notes on Section 1, Part 2. And here we are watching our video. When we're finished, you will be ready to go do Homework 2. So let's get going. Do you remember our expressions? A mathematical expression is when we write numbers and letters or variables together in some sort of mathematical sentence, like 9x minus 3. If we put an equal sign in there, then we have an equation. The only difference between an expression and an equation is that an equation has equal signs and an equation does not. I'm sorry. I'm going to go in and out, and I'm going to try to hook it up a different way. I apologize. I think we'll get rid of the setup if I do that. Okay, let's try. Now we need to look at exponents. Exponents are these raised letters here. The number that it is raised to is called our base. This would be read 8 to the second power, or we might say 8 squared. And it means 8 times 8, not 8 times 2. A couple of examples, or several examples up here of exponents. 2 to the second power means 2 times 2, 2 squared. 2 to the third power, 2 times 2 times 2, or 2 cubed. After that, we don't have any special words. We just say 2 to the 4, 2 to the 6. And it means to take the exponent, that many of the base, and multiply it together. So let's play around with some expressions. Now that we know how to deal with exponents, we can turn words into expressions that have exponents in them. So let's try that. 7 multiplied by w squared. Straightforward. 7w squared. Now, yeah, I could have said 7 times w squared, but that x would have started looking like a variable, right? So we probably wouldn't write that. I could say 7 times w squared. That would work. There's no need for those parentheses. This is the easiest, nicest, simplest way to write it. Just right next to it. Let's try another. The sum of m cubed and 12. I like the way that's worded. The sum. That tells me right away I need a plus sign. The sum of what? The sum of m cubed and 12. So that looks like this expression that says the sum of m cubed and 12. Last one, the quantity of x to the 7th power minus 5 plus 8. Crazy. You remember this word? The quantity tells us we need parentheses. The quantity of what? The quantity of x to the 7th power, okay, x to the 7th power, minus 5. That's my quantity. And then plus 8. Like that? Not too bad, right? Let's see what else we need to do. Oh, very important terms here, you guys. I can't emphasize these enough. These are beginning terms for algebra. We will use them all semester long. And I say our beginning terms, our beginning vocabulary, because our first one is the word term. A term. This has 4 terms. 1, 2, 3, 4. So just think of a term as part of an expression that can't be combined up into others. Here, this is a term, 40, x, y, z. And I'll talk more about those in just a minute. A constant term is just a number, guys. A constant stays the same, and a variable changes. So here's a constant term. 11 is a constant term here. In my final answer, -3. I'll talk about that negative sign in a minute. Is a constant term. So just a number. Coefficient. Coefficient is a number that sits in front of letters. So here, 40 is the coefficient. Down here, 6 when we look at a constant term, we don't normally talk about 3 being a coefficient, but we technically know that 3 is its own coefficient, basically. But we don't really say coefficient. We say constant when we're talking about just a number. But when there's a variable next to the number, we definitely call it a coefficient. Like terms is really important to understand. I have 3 terms here, and none of them are alike. 4x, 2y, 5z. Those are not like terms. Down here, I have 2 terms that match. They're exactly the same in their variables. So this one has an x, this one has an x. These are like terms, 4x and 2x. These constants are like terms. They're just numbers. And here's the crux of all algebra that we'll keep coming back to and keep coming back to. Like terms can be, I'm going to just start over with that whole phrase. Terms can always be multiplied. We can take the coefficients, 4, 2, and 5, and multiply those numbers. In this case, I get 40. And then we just write the variables next to it. 40, x, y, z. All terms can be multiplied. However, when it comes to addition and subtraction, you can only add or subtract terms that match or like terms. So I can only add together x's with other x's, and I can only add together constants with other constants. In this case, I add the 4x and the 2x to get 6x. I add 8 minus 11 to get -3. We'll talk, like I said, more about that later. I know you're not so great with positives and negatives integer steps. Let's move forward knowing that we have to keep looking at these words: term, constant, coefficient, and like terms. Let's play around with them a little bit. Identify the terms in this expression. This expression has 3 terms: 6x, 5y, and 3. So we would answer this guy. I'm going to ask a couple more questions. Are any of these like terms? No. None of them match in their variable. None of them are like terms. I would not be able to add any of these together. This is as simplified as this can get. How about a constant term? Is there a constant term here? The answer is yes. 3 is our constant term. The only just numbers in here. And how about coefficients? A coefficient are the numbers in front of the variable. So we would say 6 is the coefficient of this term, and 5 is the coefficient of this term. Not too bad, right? All words you're going to see all year long, so try to get them in your head. They are important. We are going to now write an expression for the measurements below. We have this little rectangle. We can think of it as our patio, perhaps. And we need to find the area of this rectangle. I hope you remember that area means you take the length and multiply it times the width when you have a rectangle. So what we need to do is take our 2 sides. One is 2x, the other one is 5. We need to multiply them together, which means multiply the coefficients and let the variable sit next to it. Notice I can multiply together a constant term with an x term. If there was a plus sign, I wouldn't be able to add them. And that's what's about to happen here. Because in perimeter, I don't multiply, I add all the sides together, right? So I kind of go around and I say, well, there's a 5 and a 2x, another 5, and another 2x. I think I'll write that this way. A 2x plus 5, another 2x, and another 5. I have a polynomial here, and we'll talk about that term later. It has 2 like terms, 2x and 2x, and I can add those together to get 4x. It has 2 other like terms that are a constant term, 5 and 5, and I can add those together to get 10. So the simplest way to write an expression for the perimeter of our rectangle is 4x plus 10. Now let's pretend quickly that we need to find the volume and that this guy has a height. So right now it's just a flat thing, but what if we thought about it as being more of a box like this, and that this height of our box, something like that, is 3. So now it's not just 2x side 5, but it has a depth or a height of 3. Well, not too bad, really. We can take all 3 sides and multiply them together. We can say 2x, because that's the formula for volume, that we take the length times the width times the height. So here's our 3, and I'll actually, no, I'll use it that way, sorry. We can multiply all the numbers. In this case, 2 times 5 times 3, I think that's 30. And then we just set the x right next to it. An expression for volume is 30x. Again, notice we can multiply coefficients even when they don't have the same variable next to them. But we can only add terms together that do have the exact same variables. And that's a really important algebra concept. Those like terms got added up into 4x, and the 5s, or the constant terms, got added up into 10. Then we had to leave it alone. We couldn't put the 2 together because they didn't match. All righty, one more and we are done for the day. You'll be ready for your homework. The reason we write mathematical expressions is because they mimic things that happen to us in real life and things that go on in the real world. Those things start out in algebra being very simple. When you get up into higher math, they start being more complicated, like flying to other planets and in outer space, and making roller coasters and all kinds of crazy things that we're able to do because we can write expressions for what's going on in our world around us. So let's start real simple with the world of going to play golf. You're going to pay $3 to get into the golf course. And then you're going to pay $2 for each hole that you play. If we play X holes, so we really don't know, just some number of holes that we're going to play, we want to write a mathematical expression for the amount of money you spend golfing. Well, a mathematical expression, that means I need to write numbers and letters. And I know that I paid $3 when I walked in the place, so I'll start out with 3. Then to that, I have to add, because I pay more than that, right? And what am I going to add? Well, I'm going to add $2 every time I play a hole. So this is a good expression for how much it's going to cost me. And what's cool about that is I can now come in and say, well, if I play 1 hole of golf, it's going to cost me 3 plus 2 times 1, or $5. But if I play 2 holes of golf, then it'll cost me 3 plus 2 times 2, or $8. And this is why an expression becomes really important to us. What if I play 10 holes of golf? Then it would cost me $23 because I had to pay $2 for every hole I played, and then after I multiply, I add. So here's a good expression that says $3 plus $2 for every hole that I play. That's it, guys. We use symbols to represent unknowns and variables. We use simplified and evaluated polynomial expressions. And you are ready right now to go and take Unit 1, or go and do Unit 1, Homework 2. If you have questions, make sure and bring those questions. You can put them in and raise your hand in LMS. You can bring them to Live CC. You can bring them to TOGA, and you can bring them to my office hours. Make sure you understand all of the questions in Homework 1 and 2. Then you'll be ready to go and take, I say quiz 3, but I think I've got that number wrong. I think it should be, you'll be ready to take quiz 1. Make sure you have plenty of time on your quizzes, because you can only go into a quiz one time. You only get one chance to go in and take it. So make sure you give yourself plenty of time to sit down and think about what you're doing. Okie doke. I'll see you soon. Take care. Bye.